Hello everyone. So today in this video we're going to discuss about the trick to identify the position of an element in the modern periodic table. It's a cool trick that you can use to find any element's group number and periodic number with this trick. So without wasting any time, let's get into the video. The basic to this trick is that you should thoroughly know electronic configuration. If you thoroughly know how to write this electronic configuration, then you can use this trick easily. You don't worry about this electronic configuration. In our channel there will be a video soon uploaded on electronic configuration, so stay tuned in our channel. So now let's come back to our concept. As we saw, the basic is we should know electronic configuration. Now let's identify the group number. The trick to identify the group number. The formula is group number is equal to number of valence electrons. I hope that you know what is valence electron. Valence electron is nothing but electrons present in the valence shell or valence orbit, that is referred as number of valence electron. Now let's see a couple of examples so that you will be clear in this group number trick. Now let's take the element magnesium. Magnesium atomic number is 12. Its configuration is 1s2, 2s2, 2p6, 3s2. So you can see here, this is the valence electron. This is the number of valence electron. Now as we saw, the formula for group number is number of valence electrons. According to this, its valence electron is 2. So we can say that it belongs to second group. That is, it belongs to 2a group. It's an alkaline earth metals. Now let's take another element such as carbon. So carbon atomic number is 6. So we can write that 1s2, 2s2, 2p2. So in this case, many of them will be confused in finding the valence electron. So you can say, as this is our same, we can consider these two as the valence electron. So what is the valence electron? 2 plus 2, 4. As it's given as a 4 valence electron, we can say that it is presented in fourth group, that is 4a group. As referring to the periodic table, we can say that it's conformly present in 4a group. I hope this trick was clear to you. It helps you to find the group number by valence electrons. Now let's get into how to calculate the period number. So now let's see the formula of that. For finding the period, the formula is just simple, that is period is equal to n number. So most of you have the doubt of what is n number. So I will give with you the example, so you will identify what is n number, so you can understand what is n number clearly. Let's take the same example, magnesium. As atomic number 12, we can write 1s2, 2s2, 2p6, 2p6 and 3s2. So generally this number is represented as the n number. This is refers as the principal quantum number, so it is the n number. So you can see in valence shell what is the n number. Here in the valence shell the n number is 3. So according to the formula, we can say it belongs to third period. Even though we have checked the periodic table, it is period number 3. Now let's look at some couple of examples. Now let's take silicon. Silicon atomic number is 14. So we can write 1s2, 2s2, 2p6, 3s2, 3p2. According to this, period number is equal to the n number. Here n number is 3. As it says, it belongs to third period. So now I hope that you have learned how to identify period and group number using this trick. Now let's see some problems. So now I'm going to give you the elements with a high atomic number. You don't worry, I will not give too high. So I will give high atomic number so that you will remember very easily. For now, let's take the first element be calcium, and another be copper, and another be chlorine, something like chlorine, and gallium. So I will give you the atomic number of this. Pause this video and take your own time to solve and check yourself whether you can find or not. Did you try it? Do you got? Okay, now let's get into the solutions. For finding group, we already saw the formula. Group is equal to number of valence electron. Here valence electron is 2. As it says, it belongs to second group, and by period you can see the n number here. N number here is 4. N number here is 4. So as it says, it belongs to fourth period. You can verify this in periodic table. Guys, please remember this is valid for not transition metals, because in some transition metals you can see some ground state and high state orbitals. In that time you can see some electrons are moving from higher to lower orbit, lower to higher orbit. In that case, this will not valid. So this is only you can say not for transition metals. You can find it for s and p orbitals. S and p blocks. So you can find there. Now let's look at chlorine. So chlorine is 17. So we can write 1s2, 2s2, 2p6, 3s2, 3p5. So here, as you know, let's take a period. For period, you know, it's n number is here, that is this is third period. And for group it's number of valence electrons. Number of valence electrons is this plus this is 5 plus 2 is 7. So it's group number 7. So I hope these examples were clear to you. By summary, we can finally conclude that period is equal to n number. N number, we already saw that. Here in this case, this is the n number. You can see this is the n number, principal quantum number. And group is equal to number of valence electrons. We saw how to what is the number of valence electrons, and how we calculate the valence electrons. So I hope this trick were clear to you. You can give me a feedback in the comment section below, and I will see you in the next video, and thank you for watching.